On number 26, we have 5x minus 3y quantity squared. Now, this is what I call a situation where we have FOIL in disguise. We don't have a property that allows us to just square 5x and square the minus 3y. You get something like 25x squared plus 9y squared or something along those lines. There is no rule of exponents for this situation, so the only thing I can do is write out two of these 5x minus 3y binomials multiplied. So this means that. And so now it's just a FOIL situation. So 5x times 5x gives us 25x squared. When we multiply our outer terms, we get minus 15xy. Inner terms, we also get minus 15xy. Notice I put the x before the y. Remember, with multiplication, order doesn't matter. We normally put the variables in alphabetical order. And then our last terms, negative 3y times negative 3y, is 9y squared. Notice we've got a couple of like terms in the middle there. We're going to end up with 25x squared minus 30xy plus 9y squared. All right, let's look at number 27. So in this case, we know that we need to divide each of the terms in the numerator by 2x squared to simplify this. So we're going to have 10x to the fourth over 2x squared minus, and then we have 8x cubed over 2y squared, and then we have a plus 10x squared over 2x squared. And so now we're just using our quotient rule to help us here. Notice 10 over 2, that's just 5, and x to the fourth over x squared is x squared. 4 minus 2 is 2, we get x squared. In the second one there, 8 over 2, we're going to get minus 4, and x cubed over x squared. 3 minus 2, we're going to get 1 when we subtract our exponents, and we don't need to write the 1. And then on the last one there, notice the x squareds cancel. We're just going to get plus 5. All right, let's move on to number 28. So certainly, we talked about when you have to factor, the first thing you should always check for is, do you have a common factor? And in fact, we do have a greatest common factor here. 4 and 8. Let's see, the largest number you can divide both of those by would be 4. We want to take the smaller of the two powers of x, that would be x squared. And the same thing with the y, the smaller of the two powers, we get y. So 4x squared y is our GCF. Now since there's two terms here, there's going to be two terms inside our parentheses. So what times 4x squared y gives us 4x cubed y? Well, the only thing we're missing is an x. You can verify that if you multiply those, you do get 4x cubed y. And then what times 4 is going to give you that 8? That's going to be a minus 2. And notice we already have x squared, and y times another y would give us the y squared, so we need a y. So again, in fact, we talk about this couple of things. Number one, look inside the parentheses. Each of those terms has nothing in common, so we know we factored out the right GCF. Now the other part of checking this, and in fact when we factor, we can always check our answers by doing multiplication. So when you do the distributive property, you should get what you started with, and in fact that is the case here. Now if you're having any problems figuring out what to put inside the parentheses, you can always divide each of your terms by the GCF. Notice here you get just x, and when you divide the second term by the GCF, you're going to get the 2y, or the minus 2y. So that's another thing you can do if it's helpful. We did 31 in the previous video. Let's go ahead and do 32 now. So notice we do need to use the AC method. We got three terms here in that form where you have the x squared term, then the x term, then the constant. Notice here we need two numbers that multiply to, in this case AC is negative 21, and our b value is 4. So two numbers that multiply to negative 21 and add it to 4. So numbers that multiply to 21, that would be 1 times 21 or 3 times 7. Now since we're getting a negative 21 here, or we need a negative 21, these numbers should be opposites. And the other thing is when we add them, we need to get a positive 4. So we want to make our smaller numbers negative. Notice the one that works is negative 3 plus 7. So again, make sure these numbers are right. Negative 3 times 7 is negative 21. Negative 3 plus 7 is 4. Let's go ahead and split our b term. We're replacing the 4x with negative 3x plus 7 using the numbers we just found. And now we'll factor by grouping. So with the first two terms, we can factor out an x times x minus 3. And notice again, when we factored the second two terms, we're expecting an x minus 3, so I'm going to go ahead and write that down. And 7 times x would give me the 7x I need. And notice 7 times negative 3 will give you the minus 21. And so that does work. So our common factor here is x minus 3. And if you cancel those out, you can see the other factor is going to be x plus 7. And again, I would remind you that you can always FOIL these two binomials and you should get what we started with. Let's go ahead and look at 33. So this time AC, again AC method, just like before, we got that form, a trinomial. And our AC here, 2 times 3 is 6. And notice our b term is 7. So we need two numbers that multiply to 6 and add to 7. That's going to be 1 and 6. So let's go ahead and split our b term and create 4 terms. Notice 1x plus 6x does give us 7x. So now we can factor by grouping. Be careful here, the only thing you can factor out is an x. And x times 2x is the 2x squared, and x times 1 gives you x. So again, when I factor these other two terms, I'm expecting a 2x plus 1 factor, and 2x times 3 would give you that 6x, and 1 times 3, or 3 times 1, that's going to give you the 3. So we end up with 2x plus 1 times x plus 3. Alright, last one on this page. Notice AC here is going to be 24. We are going to use the AC method again. And our b term is 11. And you can verify the numbers that work are 3 and 8. So let's go ahead and split our b term. And let's factor by grouping. Notice 3x is our GCF here. 3x times 2x plus 1. So again, we're expecting a 2x plus 1 when we factor the other two terms. Notice 2x times 4 would give us that 8x, and 4 times 1 does give you 4, so that is how we would factor that. And so finally we have a common factor of 2x plus 1 times 3x plus 4. Alright, we've got 2 more to go, or 2 or 3 here. On number 29, this is one of our special cases. We call it a difference of squares. Difference means subtract, and squares are numbers like 49 or 64, numbers that are equal to some number squared. And we learned that there's a real nice pattern to these. In fact, we're going to get two binomials, and the first term in each of these is going to be the same. It's the number times itself that gives you x squared. Well, that's just x. And then at the second terms, we're looking for the number times itself that gives you the 49. Well, that would be 7. We're going to make one of them positive and one of them negative, and so that's the one that's going to work. And you could verify that by FOILing it out. But we know with differences of squares, they're always going to work like this. We're going to get the same exact numbers. We're going to have opposite signs. And again, you can easily check that this works. X times x is x squared. 7 times a minus 7x gives you the minus 49. If you FOIL this out, you actually get a 7x and a minus 7x, and those add up to 0. That's why with this you only have two terms. If you actually multiply that out, you just get x squared minus 49. Alright, number 30. We have 4 terms, so we want to factor by grouping. So let's factor the first two terms. We got a GCF of x squared times x minus 2. So we're expecting an x minus 2 when we factor those other two terms. Let's see, I need x times something to give me negative 2x. That's just minus 2. Notice negative 2 times negative 2 gives me 4. So my GCF here is x minus 2. And if I cross those out, I can see the other factor is x squared minus 2. And once again, I would tell you that you could always multiply these two binomials out, and you would get what we started with. All right, last problem. So you got to be a little bit careful on this one. You might be tempted to just jump right into the AC method and multiply the 6 and the minus 9, which you could do, but you got to be careful. You're going to end up missing one of your factors. There's a GCF here. All of these terms are divisible by 3. So let's factor out the 3 first. Now, if you look inside what's in the parentheses, that's 3 terms. That is something, there is no common factor anymore, but we can factor that using the AC method. This part right here. So we need two numbers that multiply to negative 6 and add to negative 1. So you can verify that 2 and 3 are going to work. Make that 3 negative. Notice 2 times negative 3 is negative 6. 2 plus negative 3 is negative 1. So I'm just going to focus on what's in the parentheses there. We'll split our b term. When you factor the first two terms, you get a GCF of 2x times x plus 1. So when I factor those other two terms, I'm expecting an x plus 1 factor, and I need a negative 3x, so I need a minus 3 there. Negative 3 times the 1 does give me a minus 3. So we're going to get x plus 3, our common factor, times 2x minus 3. Now don't forget there's another factor. We had pulled out a 3 at the very start. Let's bring that 3 down. We get 3 times x plus 1 times 2x minus 3. Now if you wanted to go backwards to check this, you could FOIL these two here. And then once you do that, distribute a 3. So first of all, you get to what we have here, and then distribute the 3, and you'll get the starting part, the 6x squared minus 3x minus 9. All right, and that's it for this video.